A ChatGPT query uses about 10 times as much electricity as a Google search. That difference is the catalyst for a new era of energy consumption, one where our evolving technology demands are now reshaping how the US and the world power our future.
Nuclear energy at a turning point, seeing momentum as power demand jumps from electrification to data centers.
Nuclear power and technology, or big tech getting involved in it. Nuclear power has sort of gotten back into the conversation.
We're going to be way ahead of AI, and we've got to produce tremendous amounts of electricity.
We're in the midst of a nuclear renaissance right now, and that's because power demand is meaningfully rising for the first time in a few decades. And at the moment, we just don't have enough clean energy options to meet that power demand from things like reshoring, electrification, as well as data centers.
This is why big tech is betting on nuclear power. Data centers around the world, built by tech giants like Amazon, Microsoft, Meta, and Google, are hungry, not just for AI training sets, but for energy. Artificial intelligence, driven by massive computing power, is reshaping not only how we work, but also how we think about energy consumption.
What AI did is it escalated the power demand at individual data centers by a factor of 10, or even 100 if we're looking forward into the future. That means those are data centers that are needing power along the same scale as entire cities.
The Department of Energy estimates global electricity demand could rise from a third to 3/4 by 2050, with the U.S. energy grid seeing an unprecedented strain. Data centers powering artificial intelligence and cloud computing will be among the biggest contributors to this growing demand. Energy use was already slowly ticking up, but oil and gas prices skyrocketed as energy powerhouse Russia invaded Ukraine in 2022, and geopolitical volatility was on the rise.
That's really when these dialogues started to happen again in earnest, the idea of what does energy security, what does energy independence mean, and that's when we saw countries start to look at nuclear once again.
As OpenAI introduced ChatGPT to the masses in November 2022, the buzz and investment around large language models put the US on a path to an AI future and the energy demands that come with it.
It wasn't the tech companies' problem to understand how electricity worked. They knew that they could build a data center, plug into the grid, and there was enough power. And then their marketing people made sure that they had enough renewable energy credits to claim that they're actually using renewables to power their data center.
And so really right now, everyone is trying to play catch up of how are we going to meet all of these power demand goals as well as reduce our emissions. And so that's where nuclear comes into the picture. Solar and wind are great, but they're intermittent resources. That means that it's not always sunny, it's not always windy, so they aren't 24/7. And what nuclear is it's 24/7 baseload emissions-free energy.
Yeah, so this is a topic I've heard about in the past. So just a quick recap here on that. So basically the big ticket items here are, as we start to increase our demands for compute power, basically what ends up happening, especially due to AI and other things, I'm surprised they didn't reference Bitcoin in here, because I'm pretty sure Bitcoin was also another fairly recent trend where we increased power consumption by quite a bit as a society. But data centers and AI are going to be big here because you do spend a good chunk of your resources on training models, and then, as they mentioned, even actually the execution and leveraging of the models that you've previously trained can be more costly than other past systems that have existed. Because again, those were more basic. I think they even reference like a Google search. So basically, like Google would basically just kind of check for references on like how they previously stack ranked results, and then they would just compare that to the keywords that they previously had. So it's basically just like a lookup, which should be pretty straightforward. Whereas AI is pretty different because a number of steps need to happen, again, because we do like natural language processing. So you need to enter in your text. It needs to understand what those words are, what they mean in general, and like what they mean together. And then how does that translate into certain queries and like how that references the data. And so there's a lot of steps into it. And basically this is just leading to an increase in power consumption, generally speaking. And especially for these data centers. I also wouldn't be surprised with just our general trend towards more electronic usage, that there's a lot more compute power kind of behind the scenes. So this is where when we interact with apps and things like that, we have higher expectations of them being smart and them doing more computations and those things being more valuable to us. basically meaning like we expect something to happen behind the scenes, and that is going to generate a lot of value for us. And so we see less and less of that, but then we get things that are more and more valuable. I think examples are like standard web pages that we have. If you think about like 10, 20 years ago, sites and apps that you interact with today do a lot more things for you. They can be a lot more responsive. They can handle a lot more complicated tasks. And so this requires us to have a lot more stuff behind the scenes empowering that, as well as things like data sets, which they're using for AI, etc. And so this is just generally pumping up our power consumption. And so tech companies are looking at things for how they could potentially like reduce their costs, because basically they're at such a large scale now that looking at how much money you spend on your electricity is actually beneficial for them. And nuclear is actually supposed to be one of the most efficient ways of generating electricity. I think there was a downturn in nuclear power. This is probably part of this opposition section that they have here covered. But basically, due to like accidents and things like that that happened many years ago, the general public lost faith to some extent in nuclear power. But now that people are needing this a lot more, they're starting to look at these options again, like big tech companies. And they're going to pursue this themselves, because for a big tech company like a Google or an Amazon, optimizing their power could actually lead to like millions or tens of millions of dollars saved for them versus smaller players in the space. And so this is where just at scale, these things are starting to become more and more enticing for them. So we'll see what else they have to share on this topic.
Major tech companies are leading the charge. Just last spring, Amazon agreed to a nuclear power purchase agreement with Talen Energy in Pennsylvania and bought the adjacent data center from Talen for $650 million. Now, Amazon is investing over $500 million into a number of nuclear power projects ranging from Virginia to Washington State. Microsoft is working with Constellation Energy to reopen the 3 Mile Island nuclear facility, with plans for $1.5 billion in upgrades there. Meanwhile, Bill Gates-founded TerraPower is also working on a plant in Wyoming. Then there's Google, who's working with startup Kairos Power to bring advanced reactors online in the next decade, though no dollar amounts have been announced for those investments yet. Meta also says it's looking into nuclear power, targeting 1 to 4 gigawatts in new energy capacity. But these investments and partnerships are becoming an industry-wide trend, all driven by a shared belief. Nuclear is the only solution.
The tech companies have a vision of the world based on AI. That world is only possible if they produce a large amount of clean, steady power. That's why their work into nuclear now is fundamental to whether their entire world vision can come true.
These are existing and retired nuclear sites in the US with space for new reactors. The next step in the sustainable transition is to design, build, and bring those new reactors online alongside the existing ones. Enter SMRs, or small modular reactors. Unlike traditional reactors, SMRs are smaller, faster to build, and more cost-effective. They produce around 300 megawatts of energy compared to the typical 1 gigawatt output of traditional plants, and their modular designs allow for off-site assembly, reducing construction costs and build timelines. Tech and energy companies are working to bring several of these reactors online over the next decade as incremental steps toward a broader energy transformation.
You can assemble them at a factory and then bring them to the site for the final assembly versus having to build it from scratch on the location. And so that's what's traditionally been done with commercial reactors, and that's why they've often been very expensive. And so there's a lot of hope that with these smaller modular reactors that are about 300 megawatts, or even micro reactors, which can be tens of megawatts, that could kind of address some of the issues of these cost overruns.
SMRs don't operate much differently than traditional reactors, but the efficiency gains they do offer will be important for intermittently scaling our energy future.
Obviously, there's a role to build still some of these plants, but small kind of scales more naturally with how demand growth goes, especially when you look at the AI side and data center space. A lot of sweet spots are in the couple hundred megawatts in terms of total usage, but those are building up in dozens of megawatt chunks per time. So they themselves are modular. So the smaller plants really can match that growth more organically.
While SMRs hold promise, they're still a few years away. All plans in the US are currently slated to open in 2030 and beyond. Right now, there are no SMRs operational in the US, and regulatory approval will remain a challenge for years to come. There are also experts who say our nuclear solution should be a combination of these new, smaller output designs in addition to building more traditional commercial reactors.
While the SMRs are cheaper up front, they also provide meaningfully less power. And so while there's so much momentum behind SMRs, there are others that say we really need new commercial scale reactors to meet our energy goals and to meet our climate goals. And right now, there are no commercial reactors under construction in the US.
I think that for a country like the United States, the natural process is we need an enormous number of large reactors, like that's how much power we need, is that SMRs will be a way to open up the conversation. SMR gives us a term that sounds like it's new and advanced, so it makes a lot of people a lot more comfortable talking about nuclear.
Nuclear has always been very polarizing from the get-go, and then accidents like Chernobyl, 3 Mile Island, and Fukushima really kind of influenced the public discourse on nuclear and its benefits versus its drawbacks.
The 3 Mile Island power plant, the plant's reactor cooling system malfunctioned yesterday. It exposed about 8 workers to some degree of nuclear contamination.
Experts argue much of the opposition is based on misinformation.
Cars were being checked with Geiger counters.
You're not finding anything, are you, Brian?
Not a damn thing.
In today's information age, more people have access to data that highlights nuclear safety and effectiveness.
Many people think that meltdowns created the anti-nuclear movement. That's not the case. Meltdowns confirmed to the anti-nuclear movement that they were right and converted a lot of people who were previously pro-nuclear or neutral. Because there was already an anti-nuclear movement based on fear of nuclear weapons and opposition to abundant energy, it was able to reinterpret and add public fear to otherwise essentially benign accidents like 3 Mile Island.
The other main opposition to nuclear has always been around its cost. What's different this time around is tech companies have a lot of money, and they also have a very big vested interest in getting these nuclear power plants off the ground. This is incredibly long term. These reactors can be online for 60 to 80 years. And so in the long term, that nets out into a very attractive option.
I think when you look at a lot of use cases around energy growth and scale up just in history, it's often going to be dictated and driven by, where it solves the most pressing issues and the most people who are in the most pain. And I think what we're seeing is there's a crunch on that on the tech side, and that helps because those companies also happen to be some of the biggest companies in the world, which then supports, I think, some more aggressive scale up and scale out.
Depending on how long a nuclear plant's been closed and how much has been already taken apart, the cost to bring back a nuclear reactor can range from maybe $100 million in the case of a recently closed plant with no updates needed, to $1 billion or more if significant rework has to be done and parts need to be bought and installed.
Energy demand in the U.S. is rapidly rising at a rate never seen before, expected to increase as much as 20% over the next decade. Right now, nuclear makes up about 20% of our energy use in the U.S., but that share is only going to increase. While there are other factors in our increased power needs, data centers and AI are the main drivers. Market interest in AI's potential has also gone up, part of the reason for the complete shift in focus toward the technology and now its energy needs.
The problem is the tech companies eventually needed enough power that they exceeded the ability to get it from the grid. And because the grid was not well prepared for big tech, because big tech had been pushing in the opposite direction, the wrong direction for baseload power, they had to realize that they had to make it themselves. So big tech had to build out of the box that they themselves had put themselves into.
It feels like every single day there's a big new study saying, it's going to stress the grid, it's going to cause all of these problems. And so there are many in the industry who say that because it gets smarter with time, it won't require as much energy. And that could certainly end up being the case. But on the other hand, we have power demand growing from other things like reshoring and electrification. And so there is no doubt that power demand is going up.
Yeah, so that's a good point as well, which is even if technology gets cheaper to run, it can also be offset by scale and how much demand there is for that. So for a simple example would be if AI gets half as expensive to run, but people use AI twice as much as they used to, then you're still netting out to the same amount. And so this is where these things don't happen in isolation of each other. And so they are going to have to figure out how this works together. It's interesting that they have pushed, I think, something that they haven't really covered too much. They've referenced it a little bit in the last few minutes, but it's very curious how these tech companies chose to make the power stations themselves, as opposed to, well, it also looks like they have acquired some other companies who are in power, as opposed to like working with like local governments or things like that. They didn't really explain too much as to that. It seems the tech companies were saying, well, it'll get cheaper, so you don't need to build it out. So maybe they were potentially pushing on, maybe the government was looking to get higher taxes from these companies or something along those lines. And maybe they had pushed back saying that, don't worry about it, it'll be cheaper in the future, and then kind of are now in a situation where they need to fend for themselves. But they didn't go into it too deeply. But again, this is where if things get cheaper, it also depends on demand, and AI is becoming so prevalent now that it's being used for a variety of purposes. And so it likely is just going to increase the baseline expectation for many, many things. So like an app that you use today that doesn't have AI will probably have AI in the next 12, 24 months. Or a similar app that does have it is probably something that's going to draw more attention and get more users. Because if it has smarter interactions, it can do more things for you. It can get you a better output than whatever exists on the market today. People are going to lean in towards, and then those things were going to cost more energy and then have more adoption, and it can keep spiraling from there.
The bigger picture here is the growing potential of a nuclear-powered future. By driving innovation and funding critical infrastructure, companies like Google, Amazon, and Microsoft are helping to reshape the energy landscape.
I think maybe the best way to phrase it is to borrow what I've heard Sam say, which is abundant intelligence is largely built on abundant energy. And so I think tech's ability to continue to scale and deliver better things for humanity is going to be underpinned by availability of energy.
The path to a nuclear-powered future is not without challenges, though. Building new plants and reviving old ones is a challenge met with obstacles like regulatory hurdles, supply chain complexities, and long timelines for construction.
For the first time, we're now bringing old reactors back online. Right now, there's not actually a blueprint for how we go about doing this, but I think right now the industry is trying to figure out, how do we go about doing this? What are the first steps?
Yet, the momentum is clear. With SMRs set to come online in the 2030s and existing plants being revived for the first time in decades, tech is now leading the way toward a new era of energy and sustainability.
We are finally moving in the right energy direction now that the hungriest energy users in society have found nuclear energy and plan to deploy it. It's not the profitability of their investment in nuclear per se that they're chasing. What they're hoping to do is unlock a future that looks a lot like what techno-optimists dreamed of in the 1960s and 70s, when we thought we would have 1,000 nuclear plants in the US. In a way, tech, through power needs for AI, are unlocking the beautiful future we thought we were headed to before the oil shocks of the 70s.
Thank you for watching. If you've enjoyed what you've seen, please hit like or subscribe. I'll see you around.